to sixth lecture of this lecture series of optical instrumentation. I am Sharad Gupta from Kite Group of Institutions, Ghaziabad. So, we have completed unit 1 of this course and we have discussed about different optical properties of light. We discussed about theories of light, particle theory, wave theory, electromagnetic theory, quantum theory. After that we discussed about polarization and then we discussed about double refraction, Nicol prism. In previous lecture we discussed about optical activity, optically active materials, electro-optic effect, magneto-optic effect and acousto-optic effect. Now in unit 2 we have to study different light sources and light detectors. So, in light sources we have to discuss mainly two kind of sources of light, one is LED and another is lasers, different kind of lasers. So, today in this lecture we will discuss about LEDs and in next lecture, that is lecture number 7, we will start lasers. Okay. So, LED you must have already studied in your earlier year, first, second or third year. So, let us discuss it again. LED is light emitting diodes. Okay. So, in this video we will discuss about the working of LED, driving circuit, LED driving circuit, their advantages, materials that are used to make LEDs, fabricate LEDs, different kind of LED structures, and then we will discuss difference between two LED structures, that is edge emitting LED and surface emitting LEDs. Okay. So, as we all know already LED stands for light emitting diode. So, it is a diode. So, when we forward bias this special purpose diode, that is light emitting diode, then it emits light, okay, through junction region. So, it is a PN junction diode which emit lights when an electric current passes through it in forward direction. So, we all know that in diodes, when we forward bias any diode, then electric current is passed through that diode. Now, if we use a special purpose, some special purpose materials, then when this current flows, we get certain photons of different colors and we get light, and so we call it light emitting diode. Okay. So, like in normal diode, in LED also the recombination of charge carriers take place, okay, recombination of electrons and holes. The electrons from N side and the holes from P side are combined, and when this recombination takes place, the energy in form of heat and light comes out. Okay. In normal diode, this energy comes out in form of heat only, but in light emitting diode, this energy comes out in form of heat as well as in form of light. Okay. So, what is this? This is a quantum effect. The quantum theory states that when the energy of electron decreases from higher level to lower level, it emits energy in form of photon. In any material, when electron jumps from excited state to ground state or higher state to ground state, then it emits a photon of the difference of energy. It is coming from excited state to ground state, some higher energy level to lower energy level. So, it emits a photon and the energy of the photon is equal to the difference of the energy of two states. Okay. So, let us discuss the working of LED through this diagram. Okay. So, this is the symbol of LED. A PN junction diode with two arrows showing that the light is coming out. So, this is the symbol of LED. Okay. So, this is p type material, this is n type material. In p type material, holes are in majority, and in n type materials, electrons are in majority. So, these red color dots are holes and these black color dots are electrons. When we forward bias this diode, what happens? So, we have connected p type with positive terminal of the battery and n type with negative terminal of the battery. So, this positive repels each other. So, photons will move towards the junction, and in n type semiconductor, electrons will move towards the junction. At the junction, what will happen? Electron hole recombination will happen as it happens in normal diode. Okay. So, when electron combines with hole, then they release a particular photon is released. Okay. So, we shall discuss this with the help of band diagram. Okay. So, this is energy band diagram, this is conduction band over here, this is valence band. Okay. So, there are free electrons in conduction band over here in n type material, and there are vacancy. In p type material, what is a hole? A vacancy of electron. So, there are vacancies of electrons. So, this is absence of electron in p type semiconductor, this happens due to doping. Okay. So, there are free holes in valence band and there are electrons in conduction band. When we forward bias it, what will happen? The electrons will move to junction region, the holes will move to junction region, and electrons will combine with holes. So, from conduction band they jump to valence band. So, from conduction band, when the electrons jump to valence band for recombination, this difference in energy of conduction band and valence band, conduction level and valence level. So, what will happen? The difference of this energy will be emitted in form of photon, in form of photon. Now, we have to choose these materials, we have to choose materials to construct LEDs such that this difference in energy is such that the photon that is emitted, its wavelength fall in visible region. If the wavelength of this photon is in visible region, then we can see the light coming out from LED, from this diode, through our naked eyes. This happens always in normal p-n junction diode. When electron hole pairs recombine, a photon is emitted, but it is mainly in infrared region or in some other region that we cannot see from our naked eyes. Okay. So, maybe they emit energy in form of heat, but if we choose this forbidden gap such that the difference in energy, what is the difference, what is the h nu, energy of photon is h nu. Okay. Planck's constant into frequency. Frequency. What is frequency? Okay. So, we have to choose that such that this lambda lies in visible region, this lambda lies in visible region. So, if this happens, we can see this light from our naked eyes and we can use such material to construct LEDs. So, LEDs are diodes that are made using special materials. Okay. So, this is the working of LED. This is an LED driving circuit. So, we cannot simply connect LED with directly with a battery. So, if it will burn the LED, because a huge amount of current will flow in the forward bias condition and LED will burn. So, mainly we have to use a current limiting resistance, we have to always use a current limiting resistance with LED. So, what we can do? We can either simply make this circuit, we can use a resistance and we can connect an LED and with the battery. So, this will also work, the LED will be on, but we normally have to control LED through some another signal, right. So, this is current limiting resistance and this is LED. So, this circuit will also work, but if we have to connect LED with a microcontroller or with a microprocessor, and if we wish to control the LED using some program, then we normally use this circuit. So, what will happen? Whatever is the controlling signal, we connect that signal over here, for example V1. If plus 5 or any positive voltage that is more than 0.7 volts is applied on this point, then what will happen? This transistor will start conducting, and when the transistor starts conducting, the LED will be on, and this resistance will limit the amount of current. Okay. This resistance will limit the amount of current, but if we have to switch off this LED, then in place of this 5 volts, a 0 volt will be applied, the transistor will not conduct, current will not flow in this path, LED will not get forward bias, and we will not see any light. Okay. So, a simple transistor can be used for on off of a LED as shown in the figure. The base current IB conducts the transistor, and the transistor conducts heavily, the resistance RC limits the current of the LED. Okay. So, this is a very simple LED driving circuit, but it is not used normally. We can normally use this circuit in our projects. Okay. So, what are the advantages of LEDs? LEDs are used everywhere, in our TVs, in the screen of our mobile phone. We can see LEDs everywhere. Okay, in various display devices, 7 segment displays, everywhere LEDs are there, and it is very efficient. So, let us see why LEDs are used everywhere. What are the advantages? So, one advantage is they are smaller in size, as it is a diode, it is a semiconductor device. It can be fabricated in a very small size. SMD LEDs are also available, they are very small in size. Also, they can be stacked together to form numeric and alphanumeric displays. Okay. So, we have seen numeric and alphanumeric display while using projects, or in our day to day life. If we pay attention, you can see various numeric, alphanumeric display around you. Okay. Just do one thing, check where are these displays and count them. You will find numerous display around you. Okay. Next is the intensity of the light output depends on the current. The intensity of the light, it depends on the amount of current flowing through the diode. So, we can control the intensity very easily by controlling the amount of current, and we can very easily control the amount of current by changing the value of the resistance, or also by changing the voltage. And there are few more methods through which we can control this flow of current, and we can control the brightness of the LED. Okay. So, the intensity of the light can be controlled smoothly. It is very easily and smooth to control the intensity of the light that is emitted from LED. The LEDs are available which emit light in different colors like red, yellow, green, amber. So, there are various colors in which LEDs are available, different colors for which LEDs are fabricated, can be fabricated, and they are available. Okay. LED TVs are most costly TVs. If you see true LED TVs, they are very sharp and they are very good in display. Okay. Also, on off time or switching time of LED is very less. It is of the order of 1 nanosecond. So, we can very rapidly switch on and off any LED without burning it. Why? Because the switching time is only 1 nanoseconds, so small. 10 to the power 9 times we can switch on and switch off an LED. In our household also, we can see LED bulbs are there, even tube lights are made of LED these days because they are very efficient. The amount of light that was given by a 100-watt bulb, that amount of light is given by a 9-watt LED. So, it consumes very less power. Also, its life is very high in comparison to a simple bulb. Why? Because this switching time is very less. Okay. The LEDs are used for dynamic operation. Due to this, LEDs are used in dynamic operations also. Okay. Few more advantages: they are very economical and they are very reliable because they are fabricated by using same semiconductor technology as transistors. They can be operated in a wide range of temperature from 0 to 70 degree. They are very durable and they can take shock and vibrations. Okay. Efficiency is high. Efficiency is high, that is why they are used in place of normal bulbs and tube lights also. They are used everywhere, but they require moderate power for operation. Typically, the voltage is 1.2 volts and the current of 20 milliamperes. They need DC power supply to operate. Okay, so we have to convert AC supply to DC. Okay. For full brightness, so very less current is required for full brightness, only 20 milliamperes. So, they can be easily used in such places where less power is available. Okay. Materials that are used to fabricate LED, there are various materials: gallium phosphide. Okay. So, doping, if we dope it with nitrogen, it will give green color light. If we dope it with zinc or oxygen, it will give red color light. Okay. So, you can see peak wavelength of the light that is emitted, and this is the quantum efficiency of particular material LED. Gallium arsenide, silicon is the dopant. This is infrared LED. We cannot see the output with our naked eyes. This is infrared LED. Okay. Then again gallium arsenic phosphide with different ratio of arsenic and phosphorus. So, in this 0.35 is arsenic, 0.65 is phosphorus. So, different ratio for different colors: orange, yellow. Gallium aluminium arsenide, again the dopant are same. This is for infrared, this is for red, and over here we can see external quantum efficiency. These are few materials that are used to fabricate LED. There are various more materials that can be used, and also continuous research is going on to find out new materials, more efficient materials to fabricate LEDs. Okay. Now, let us discuss different type of LED structures. Mainly in this lecture I shall be covering planar LED, dome shaped LED, heterojunction LEDs, surface emitting and edge emitting LEDs. Okay. So, this is the simplest of all LED structures, planar LED. You can see this is P type material. Okay. and this is N type layer, this is N type. One second. So this is P type. So P type is very thin, so that light can come out of because electron hole pairs will recombine in the junction region. So that light can come out through P side. So this is very thin. So what will happen when we forward bias this LED? Also we have to okay. So light will come out from this side. So P type diffusion into N type substrate, light emits from all the surface. So this is the simplest LED, planar LED, not normally used these days. Next is dome shaped LED. These are dome shaped LEDs. We normally use such LEDs in our projects, right? So this is the internal construction of dome shaped LED. Over here you can see a very small PN junction, and this is a cathode terminal negative, and this is anode for P side positive, right, and this is cathode for N side, this is negative. So we have to connect battery, negative terminal on this leg and positive terminal on this leg. So this will switch off the LED, and a plastic dome is used to so that LED will be emitted in all the directions, light will be emitted in all the directions. Next is till now we have discussed LEDs that are homojunction. Okay. Now what is a homojunction and heterojunction? You already know what is homojunction and heterojunction. If a PN junction is formed using same material, then it is called homojunction, but if the doping is different, then it is called heterojunction. For example, you can see here efficiency of heterojunction LEDs is better than homojunction. So over here this is gallium nitride, this is aluminium gallium nitride, this layer is indium gallium nitride, again aluminium gallium nitride, and again gallium nitride, and this is the substrate of silicon carbide. Okay. So these are called heterojunctions, and they give better efficiency in comparison to homojunction LEDs. So again you can see this is P side, this is N side, we will have to connect positive terminal over here, negative terminal over there, and light will come out from this. Okay. Next, there are mainly two kind of heterojunction LEDs. First is surface emitting LED and second is edge emitting LED. So this is the construction diagram of surface emitting LED. Okay, two diagrams showing same thing. So it is mainly used in optical fiber communication. So you can see a optical fiber is coming over here, and it is attached here using a bonding material over here, using a bonding material it is attached here, and this there is a circular etched well, there is a well that is made here, so that the light that is emitted immediately enters the fiber. Okay. So this is substrate and these are contacts, metal contacts. You can see over here there is a silicon dioxide isolation layer, silicon dioxide isolation layer, and this is a double heterojunction layer, double heterojunction layer So, the efficiency will be more in comparison to homojunction, the light will be emitted and will enter the fiber. Over here aluminum gallium arsenide and this is gallium arsenide. So, this is a double heterojunction layer, fine. Another is edge emitting LED. Why it is called edge emitting LED? As you can see from the diagram, because the light is coming out from the edge of the LED over here, and in previous one the light was coming out from the surface. Okay. So, that is why it is called surface emitting, and in here the light is coming out of edge. So, due to this construction the name is surface emitting and edge emitting LED. So, dimensions are shown here, it is very small, only even smaller than a millimeter, right, 350 micrometers, width is 80 micrometer, this is 200 micrometers, and again this is a heterojunction LED. You can see aluminum gallium arsenide and light comes out from this edge, and these are metal contacts. Okay. So, let us discuss what are the differences between these two heterojunction LEDs, surface emitting and edge emitting. So, these are the differences. Surface emitting LED is easy to, in surface emitting LED construction of heat sink is easy, but in edge emitting LED it is more difficult to construct heat sink. Heat sink we must construct because some of the energy is emitted in form of heat, and that has to be we have to remove that heat from the junction from the LED, otherwise it will burn. So, we need heat sink. It is easier to make heat sink in surface emitting in comparison to edge emitting. It is easy to handle surface emitting LEDs, and edge emitting LEDs are difficult to handle. Surface emitting LEDs are cheap in comparison to edge emitting LEDs. So, because they are simple to fabricate, so that is why they are also cheaper. Edge emitting LEDs are difficult to fabricate, it is difficult to fabricate heat sink also, okay. It is difficult to handle them. There are no critical tolerances in surface emitting LED, in edge emitting LED there are critical tolerances. Again simple to operate, it is difficult to operate. But surface emitting LEDs are the reliability of surface emitting LEDs is less in comparison to edge emitting LEDs. Surface emitting LEDs are very less reliable, and there is this is the main advantage of edge emitting LEDs, that they are very reliable in comparison to surface emitting LED. Also their line width is wide, and in edge emitting LEDs we can get narrower line width, okay. We can get a narrow beam of light in edge emitting LEDs, okay. So, these are the major differences between these two kind of LED structures, surface emitting and edge emitting. So, this was all about LEDs.